Hi, Assalamualaikum warahmatullahi wabarakatuh. Right now, me and my groupmate will present about the drainage and sediment basin design at Taman Airis Parit Raja. First of all, let me introduce myself. My name is Muhammad Faris bin Muhammad Rahim, and my matrix number is CF210320. For the introduction of our project, we are required to propose the design of drainage and sediment basin system that comply with the standard and regulation of local authorities to achieve an efficient drainage and sediment basin system. The choice of location for this project is in Taman Airis Parit Raja. There are two objectives that we gain in our project, which are to design drainage and sediment basin for construction site, and the second one is to construct structure that transmit water for the channel design. So here it is, our location at Taman Airis Parit Raja, which means Taman Airis is next to Taman Malewa at Parit Raja.
Assalamualaikum. I'm Muhammad Tajuddin Arif bin Tajul Arifin. I will present about the drainage design. Okay, for this project, we consult the MSMA second edition to learn more about the channel categorization value. The value helps with the next step, which is to compute the rain velocity using the Manning coefficient. Furthermore, the values of lambda, k, theta, and n can be ascertained with the use of this reference. We have chosen Sector JPS Batu Pahat as our location since it is the nearest to the project's construction, which is the Taman Manis. Estimate the drainage for 100 years and use TC for 20 minutes to get the precise amount listed in the MSMA second edition. To calculate the design flow for engineered channel, we need to calculate the rainfall intensity and flow rate for 100 ARI. From referring to MSMA second edition, we can derive the parameters of lambda, k, theta, and also the meaning to calculate the intensity of rainfall, which is used to formula and we will get 241.21 mm per hour. This intensity will be used to calculate the flow rate using the formula Q equals to CIA over 360 and we will get 1.163 meter cube per second. Next, we will calculate the rainfall intensity and flow rate for 0.25 ARI, which is for 3 months. Okay, from the MSMA second edition, we can get the derived parameters, which is the lambda, k, theta, and the Manning coefficient. Next, we will use the intensity formula to get the intensity of the rainfall, which is 75.15 millimeter per hour. Next, we can use it to calculate the flow rate by using Q equals to CIA over 360 and we can get 0.362 meter cube per second.
Hi, my name is Anamara Isel Ana James, CF200232. Okay, continue for the drainage design. For the low flow invert, our group has chosen the trapezoidal channel grass channel shape with the Manning roughness coefficient N 0.035. So we assume the design cross section where we use the channel longitudinal slope 0.003, and then for the bottom width 1.2 meter, top width 2.5 meter, side slope Z 0.5, and with the depth 0.5 meter. So based on the design, we get the discharge Q equal to 0.53 meter cube per second, which is higher than our Q low flow 0.362 meter cube per second, and it is okay. And then checking for the flow velocity V, we get 0.72 meter per second, which is still in between 0.6 meter per second until 2 meter per second, and it is also pass. Okay, next proceed to the grass channel design, where the bottom width we use 3.5 meter, top width 4.3 meter, side slope Z 1.5, and depth 0.8 meter. So for the discharge, we get 1.29 meter cube per second, which is higher than our Q100, 1.163 meter cube per second, and it is okay. Lastly, check for the Froude number. We get 0.38, which is lower than 0.8. So to conclude, our grass channel has subcritical flow. Okay, that's all from me. Thank you very much.
Hi, my name is Muhammad Ashraf bin Abdul Rahman, and today I would like to talk about sediment basin design. Sediment basin design aims to capture and settle runoff sediment before it reaches natural water bodies. It includes a forebay for larger particle, a sedimentation zone for finer particle, and an outlet for treated water. Design factor involve sizing based on flow rates, proper slope for settling, and maintenance access. Okay, first we talk about the determination type of soil. The type of soil is coarse grained sand, sandy loam. So dry sediment basin is selected. So for the table 2 is determination of basin dimension. The required surface area is 121 meter square per hectare, and the required total volume is 145 meter cube per hectare. The surface area required for the site is 255 meter square. Note, this is the average surface area for the settling zone volume. The total basin volume required for the site is 280 meter cube. Next, we talk about settling zone. The required settling zone V1 is 140 meter cube, half the total of the volume, and the selected settling zone depth YF equals to 0.6 meter. Okay, so we try a settling zone every width, which is 50 meter. Then we get 7.8 meter. So we take 8 meter, and the average surface area is 400 meter square, and it's larger than 233 meter square. Then it is okay.
Determination design flow for the drain. So for the formula is I equal to lambda T to the power of K over D plus theta to the power of N, where I equal the average rainfall intensity for selected area and storm duration. T equal to average recurrent interval area. D equal to storm duration. So this is our table and data. For the calculation, we have get 241.21 mm per hour. So this is a three method that we have calculated. It is rational method, sizing spillway, determination of Q riser. For the rational method, we have get 0.77 m square 3 per s. Try with 1 or 5 with diameter 0.45 at the same level. Allow head 0.3 meter from the centroid of orifice. So the second one is determination of Q riser. Q riser, we get 0.23 m square 3 per s. Therefore, allowing for the riser pipe flow, the required spillway capacity. The sizing spillway, we have get 0.62 m square 3 per s. Therefore, the total basin depth including the spillway is we get 2.2 meter. Trapping efficiency. The design store will yield 70 tons of sediment with 90% trapping efficiency, capturing 63 tons, 39.38 cubic meter. The 140 cubic meter basin can accommodate float first sediment, taking about 3 even to fill 140 cubic meter per 39.38. Assuming a 3-month area for the design stock, the storage zone may fill within a year. So this is our plane and section, and downstream elevation.
The discussion of our project after we did analyze and calculate our data for the drainage design, the analysis data shows that the peak flow is 1.163 meter cube per s and the average rainfall intensity is 241.21 millimeter per hour. The flood number for a drainage is subcritical flow, which occur at depth of flow larger than critical depth. For the sediment basin, our flow rate or Q spillway is 1.62 meter cube per s is bigger than flow rate, which means Q required is 0.54 meter cube per s. There are three events would be needed to complete fill the sediment storage zone in 1 year. Finally, the conclusion of our project. After we did all the analysis and the calculation, we learned that sediment basin design is at the forefront of erosion and sediment management strategies and tackles significantly environmental concerns in mining, agriculture, and construction, among others areas. The design of sediment basin is always being enhanced by scientific and technological developments. Improvement in construction material, monitoring system, and engineering technique lead to more efficient and environmentally friendly design.